Hello and welcome to Alex Explain F5. Today we're going to talk about distributed cloud, F5 distributed cloud for sure, and we're going to talk about service mesh, that apps can interconnect each other wherever they actually locate. But if we really seriously talk about this technology, we need to consider redundancy, we need to consider high availability. And if we look into documentation on the service mesh concept, I see that there are these nodes that can be located pretty much everywhere in any kind of private or the public cloud, but how to make them redundant. This is what this video is about. Today we'll show you that setting up the redundant way of this customer edge or the service mesh node is really easy. For that, I'm going to use my private data center emulation with the F5 Unified Demo Framework. I got a small test environment with the single subnet where I got my client, my server. Let's add customer edge nodes. I got a few images and I will add customer edge nodes. I need few of them. It's actually free because the customer edge cluster need at least 3 nodes to create high available group or the cluster. This is how the technology is based on works. One node that fails can come back and take configuration that's available on more nodes than just one. It's 2. So this is why actually it's at least 3. So I got my 3 nodes. By default they connected to this network and we just need to boot that up, start this environment. It takes some time to boot. And when it's booted, we are ready to configure it. I'll use the web interface that is available by default and can be accessed with the default credentials of admin and all their 1, 2, 3. And I see the dashboard and I need to configure the node to be connected to the distributed cloud. And the first thing I need is a site token. So here is the first thing. I go to my distributed cloud console. I need multi-cloud network connect to manage the sites. To manage the site, I need this token. I have one. And actually I can reuse it. I go to my CE. Then I need a name for the cluster. It's a private site, so let's name it like that. Host names must be different for each node. And this is almost about it. I need just one network interface CE node. This is more than enough for my setup. I need to put my geographical coordinates to help to connect the CEs to the closest regional edges. And this is pretty much it. I'm saving the configuration and I need to repeat it one more time, or actually 2 more times. And we're good. So now let's go to the distributed cloud console and we should see site registrations. Yeah, here we start to come from this node 0, 1 and 2. So I'll accept this registration. Here I just put that I need 3 node cluster, so it can expect 2 more to come, and I need just parameter what type of the tunnel I can use. I don't really care about it right now. So we're good to go. We accept registration. We need to accept 2 more. So we accepted our registrations and we can go to the sites and see what is going on here. We see that site is appeared and the state is provisioning. We need to wait a bit for this site to become available. And so far I introduce you with my demo application. So we go to the server. With the server, it's actually pretty straightforward. I run the Docker. Here I can start the test application that we use in F5. That is pretty much showing the technical data. It's got the graphical and the text version, so we can see that it's actually running. Seems to be running. Let's go to the client and check what we got here. My client is also Ubuntu server. I'm not complicating. Let's go 10.1.1.4 if I'm not mistaken. And we need a text version. No, it's port 8080. Yeah, this is my demo app. So my client IP 1.5, and this is internal cluster IP of the Docker network. So yeah, we got test application running. Let's have a look what is with our site. Okay, site is getting better. Health score is increasing. Yeah, it's totally fine. And we can start to understand what is going on. So we see that we got a free master nodes, that is the open running, but we see that there are two tunnels from just different nodes, but not from all three of them. The traffic goes to the cluster and then distributed inside it, if it's connected through the RE. Let's try to build a scenario. Let's publish application outside over regional edges using our CE as an origin. With that, we go to multi-cloud app connect, create our origin pool. So private UDF workload, port is 8080, and we need IP address on the given site. So site is this one, and the IP address is 10.1.1.4, and we need to use outside network because we got only one interface. It's good. It's worth to get a health check. Yeah, no TLS there. Good. So we get our origin. Let's publish it with the load balancer. I have my zone here. Private workload. This is going to be my domain name. I need to name load balancer. It's going to be HTTP for us to easy to see what is going on, but I need a DNS record for that. I add the origin, the one we created, that's right. And yes, this is it. I need to publish it to the internet. Good. Save. When our host is running, let's see. Open the tab for this hostname that we created. Yeah, and we see the application. It's graphical version, but we know that it's also the text version is right over here. Yeah, we got exactly what we saw in the lab locally. So we published our application outside, and the way it works, if we go back to documentation, it's basically connect the users outside of internet and then through the tunnel down to my node, and then distribute the load to the nodes. So we can actually see which nodes are providing connectivity. Okay. Now let's move to another example. So if I need to publish it locally for my client on a CEs, how it'll work. Let's configure that. We will use the same origin, but we create new load balancer. With the domain name that is going to be, I don't know, yep, something like that. It's again going to be HTTP, but I will use the port 80 for the proxy. I cannot manage automatically DNS on a local provider. I just need the same origin, and the way I publish is going to be custom. I need to provide it on a given site. This is pretty much it. I need to publish it just on that site. And before this save, let's see what is going on. So if we go to the client and go to one of our nodes, it's pretty much nothing is happening. So nothing is responding because there is no application published there. We can even add the host header with our name. Yep. Still nothing. Okay, let's publish the app. Accept the configuration. And it should be published in a second. Yeah, and now we got that our node is actually responding to the request to the port 80. And interesting thing that all of them, .6, .7, and .8, provide the access to this application. Each of them is proxy. So if I go to port 8, the client IP is knotted to .8. You need a broker, load balancer, if you publish application locally to distribute to different nodes. Couple of interesting moments how the things are working. So if we delete the host header, nothing will happen. It uses the host header or SNI routing depending on the protocol. And one more thing, if we go and try to resolve our quite internal name against one of the node, any of them, it's going to be resolved. So you can point your DNS server for particular names or for all unknown names, or use it as a forwarder to the node, and then applications will connect by the host name. Whatever service on my local site is going to use this wl.example.internal is going to be resolved if resolver on the C. So with that, I built my site with the redundant configuration of the customer edge, and I published application locally here and globally to the whole distributed cloud. Hope you got the idea how the things are working, and they, I think, pretty easy to configure. See you next time. Thank you. Bye-bye.